This is CET236 and I'm just going to do a quick run through Lab 8, which is Phasors. So let's have a look at that. So here we've got on the left hand side of the screen I've got LT Spice, and on the right hand side I have Lab 8, and the idea is we want to measure the voltage across the resistor and the voltage across the capacitor with a frequency, with a voltage source of 500 Hertz. So let's go ahead and draw the circuit. I'm going to do my usual trick of drawing the outline first and then adding a voltage source, and we want to make it so we want DC value of 0, we want no, we want a different voltage source. So let's try that again. This time we'll go with an AC voltage source. Oh, it should be the same one. We do get sine, so let's maybe it when I clicked on the advanced piece it didn't give me, oh, I've got to select it up here, that's what it is. Right, so here I want sine, I want 0 DC value, and I'm going to choose an amplitude of 10 volts, that's okay. The frequency we want is 500 Hertz. I don't want any delay, I don't want any to say any particular, so that should be enough to get us a sine wave, and it'll print it up there as you can see. And then we want to do a resistor, okay, and we want to rotate that, Control R, and we want to give it 1000 ohms or 1 kilo ohm, and then we want to put a capacitor on there, and we'll do that, and the capacitor value is 1 microfarad. You can write 1 U, which converts to the mu character rather than U, so we get the right thing there. Now remember, I've also got to put that oops, I want the net name, and I want to give it a ground symbol, so there, and then I need to connect up my ground like that, and there's our circuit, and then I should be able to run that. I need to also add a spice directive, and just .tran1 should be sufficient for this one, and I just put it up there, and then we can run it again, and looks like we've got there's the plot. So let's grab the voltage across the resistor and then the voltage across the capacitor, and that's what's happening there. We've obviously got far too much happening, so what I want to do is I want to zoom in, okay, and you can see there's a difference in the phase between the two, and what you probably want to do is let's just go back and read. So there we can calculate the peak, we can measure the peak using LT Spice, and then the aim is to measure the phase delay, rather the time delay, and then the degrees delay between the two. So to do that, we can go up here and maybe Right, so there's our there's one. We get the peak of that one, and then we can double click on that one, and it's decided to change it over. I don't know. There we go. No, that's now we've got both of them. Now we can select N2 maybe. Right, so then we can maybe get the peak there. Right, so now I've got the peak on the green one selected, and I've got the peak on the blue one selected, and you should be able to see that the horizontal difference is 519 microseconds. Okay, 519 microseconds. And let's just grab a new page in here. Lab 8. Right, so our time delay, our delta t was 519 microseconds, right? Which is 519 by 10 to the minus 6 seconds. And we had a frequency of 500 hertz, so 500 times a second, which means we have a period of 2 milliseconds, or you could also write that as 2000 microseconds. So that means that our angle delay, our delta theta, is going to be delta t, which we measured up here, divided by the period times 360 degrees, which is going to be 519 on 2000 times 360 degrees. And let's just bring up MATLAB and see what that says. Right, so 519 on 2000 times 360, 93.42. Right, which is 93.42 degrees. And the idea is, right, what we've just done is we have one period, right, that's our period of the sine wave, P, and we've measured a part of that sine wave, delta t. And the other way to think about this is that this is 0 degrees and this is 360 degrees. So the way to get the angle delay is by delta t on P, the period, the time difference between the two traces, and the period times 360 degrees. And that'll tell us what this position is here in terms of degrees rather than in terms of seconds or microseconds. And that's pretty much it.